Alright, so I'm here to discuss to you simultaneous equations involving one linear and one nonlinear equation. So what would be the objective for this lesson? So we have to recall your algebraic methods that are used to solve quadratic equations. So it's just a simple recall, not really discussions that will involve another session then. And of course, we have to solve simultaneous equations involving one linear and one nonlinear equation accurately. You have the word accurately, so we'll see later how do we do that. All right, so suppose you're given your x plus y equals 8 and the other one is x squared plus y equals 10. We can identify that this x plus y equals 8 is what we are saying linear equation, and x squared plus y equals 10 is nonlinear equation. So we have to think of how come it's nonlinear. Okay, so when we are dealing with a nonlinear equation, you have to recall how to solve a quadratic equation. Since mostly in this lesson we will encounter a quadratic equation, so I'm telling it to you now right away. And we have three identified algebraic methods. First, we have your factorization method, the easiest, I guess, and most of you are familiar with it. The other one is completing the square. It's a little tasky, but you can do. I know you can do it. And whenever the two are not applicable, you can use the quadratic formula method. Now let's see this graph. You can see two graphs here. One graph, this one is in red and then blue. Red and blue graphs, and they got this intersection and another intersection here. So we name the graph as, or the two graphs as x minus x, or y minus x equals 1. Sorry for that. And the other one is your y equals x squared minus 5. So we got here point of intersection and another point of intersection. So how do we know these points then? This is now we are to apply your solving the simultaneous equations. So it's a must that you have to identify which of the two equations is your linear equation and nonlinear equation. So in this case, our first equation, y minus x equals 1, is your linear equation. The other one, most probably, is the nonlinear equation. In solving, it's important that you can rename them, or you can rename the equations as, or your equations as equation 1 and equation 2. There, it's easier to remember. So let's start solving. So we have to solve for x by substitution. So how are we to do it? You will notice that equation 2 is already expressed as y in terms of x. So meaning the variable y will represent or will be represented by x squared minus 5, in which from equation 1 we can replace that variable y by your x squared minus 5 and no more variable y. So we can now concentrate with the variable x. And from there, we can solve what is the value of this x. So you have x squared minus 5 minus x equals 1. And we have similar terms here, which are negative 5 and positive 1. So we can combine them. And by the addition property of equality, we can add positive 5 here to make this 0, so it will be gone since we're dealing with equations. So you have whatever you have done on this part left side, you have to do on the right side as well. So we added 5 here and it will be 0, and what remains on this side is your x squared minus x. Since you added 5 here, you have to add 5 on the other side. That would give you 1 plus 5. And we simplify this. This is 6. But since we have said equation, so it's easier to solve an equation on this type if we are to equate this to 0. So since this is positive 6 and what we are saying the transposition, positive 6 will go on the other side And whenever it will pass through or go on the other side, it will change its sign. And that's from the concept of addition property of equality. Since we are to add a negative 6 here, so you just imagine we got 6 and then minus 6, it will be 0 on this part. Since we added negative 6 on this part, we have to add a negative 6 on the other part. And we rearrange. And you have now x squared minus x minus 6 equals 0. Now we got here a quadratic equation that is factorable. So you have your two binomials. So we need to factor x squared, that would be x and x. And then you go to the last term, negative 6. So you have to think of what could be the numbers that you can multiply for you to have 6 as the answer. So you have 5, 1, 3, and 2. Now, since your middle term is negative, so you have to take into consideration between 3 and 2, which will contain the minus or the negative and the plus. Is it the 3? Is it the 2? As you write your binomial. So remember, you have x already, x on the first binomial and x on the second binomial. And you have 3 and 2. Now replacing 3 and 2 will be a little tricky. And what you have to take into consideration is the sign of your middle term. Since it's negative, so it's minus, it's negative. With the factor of 6, you check into which is higher. So between 2 and 3, 3 is higher. So therefore, 3 will contain the minus sign or the negative sign. So what will happen to 2? 2 will be positive. So it's now x plus 2, and the other binomial will be x minus 3. I hope you were able to recall that factoring process. So since we have two binomials and still they are equal to 0, so we separate them. You'll have x plus 2 equals 0, and the other one is x minus 3 equals 0. Since we're solving for x, you just simply transpose your positive 2 on the other side, and again it will change the sign. And you have to transpose your negative 3 to the other side, and again it will change the sign. And what we have is your x is negative, x is negative 2 and x is positive 3. Sorry for that. Okay, so we have a negative 2 and positive 3. Now, so I just include it again on this slide. So we got your x coordinates, and you're ready now to solve for your y coordinates. Now between the two equations, your y minus x equals 1 and y equals x squared minus 5, you just have to decide which of the two you are comfortable in working with, as you are to substitute the values that we got. So I'll choose equation 1, y minus x equals 1. Since there's no squared term, it's easier to manipulate. So we have here substituting negative 2 to your equation 1. So you'll have 1 minus a negative 2 equals 1, and that will give you a negative 1. And then you do the same on when x is 3. So we have y minus x equals 1. That will give you y equals 4. And summarizing, we have the solutions. When x is negative 2, your y coordinate is negative 1. When x is positive 3, your y coordinates will be negative or positive 4 rather. And we check that on our graph. So we got there now the solutions for the simultaneous equations. You have the coordinates negative 2, negative 1, and then 3, 4. And that's how you solve simultaneous equations involving one linear and one nonlinear equation. So I hope you've learned something, and I'll see you again with the next lesson. I'll try to upload as soon as possible. Thank you.